For this problem, we want to find a function in standard form that can represent this function described. So they've given us the zeros. From the zeros, we can come up with the factors. And then from the factors, we can come up with a standard equation. So for a 0 of 0, multiplicity 2. This comes from a factor of just x. And because of the multiplicity 2, this would be squared. For a 0 of 1, the factor would need to be x minus 1. Multiplicity 2 would also be squared. Now, 5 halves, we could do x minus 5 halves squared, but that's not going to multiply out well. So another thing we can do is simply bring this 2 up out in front. So instead of this factor, we get 2x minus 5 squared. Let's just take a look for a minute why these factors are the signs they are. If it's 1 for a 0, why do we have minus 1? Basically, how we find the 0 is we set the factor equal to 0 and solve. So if we add 1 to both sides, that's what gives us the positive 1 for the 0. If we do the same thing here, 2x minus 5 equals 0. Plus 5, we're going to convince ourselves that this is right. Divide by 2. There's where we get our 5 halves is our 0. So let's go ahead and rewrite this with the factor that we have changed. Okay, this is step 1. Now we need to get this in standard form, which is going to be a little bit of a project in itself. So what we can do, it doesn't matter how we multiply these. We have to multiply all these together. So I am going to start off to the side here, x minus 1 times x minus 1, and FOIL it. That gives me x squared minus 1x minus 1x, which is minus 2x plus 1. And then if I do the same for this, FOIL it, I get 4x squared minus 10x minus 10x is minus 20x plus 25. So with that work, this becomes x squared minus 2x plus 1, 4x squared minus 20x plus 25. I've got to keep going with the multiplication. We can do this as sort of a triple distributive property, but I think the easiest way to multiply these two trinomials together is in this table format. If we make a 3 by 3 table and we say x squared minus 2x plus 1 here, 4x squared minus 20x plus 25 here, we're going to multiply these together and put the result in each of these squares. So 4x squared times x squared is 4x to the 4th. I'm just going to keep going with this. 4x squared. Actually, the times 1 is the easiest. So I'm just going to do this for each of these. This will be minus 20x cubed plus 40x squared, 25x squared minus 50x. And then I need to see what are my like terms. So I can see I have the cubes here, squares there, x, oops, I wanted to do a different color there, x's here. So if I combine like terms, I also can't forget that I still have my x squared here. I haven't done that part yet. Oops. This gives me 4x to the 4th minus 28x cubed. 44 plus 25, 69x squared, 70x plus 25. And finally, to get this last one here, distributive property, 4x to the 6th minus 28x to the 5th. I'm adding these exponents is the right way to multiply. Plus 25x squared. And finally, that is my polynomial answer in standard form.